Let's continue our discussion on lesson 5.4, solving systems of equations in two variables. And this time we'll be working on the algebraic part of solving systems, and that would be by substitution and by elimination. So pretty much these are the steps when solving systems of equations using substitution, but instead of me going over these steps, I'll just explain it to you while we work on an example, all right? So from the name itself, it says substitute. So we will be substituting one of the variables. So we always have two x and y. So we will replace one of them as an expression that is defined by one of the equations here. So for example, we have these two linear equations. Y equals negative x minus 1, and the other one is 4x minus 3y is equal to 24. So here, it's easy to find out which variable to substitute because you already have this particular part here. It says here that y, the variable y, is equal to, okay? So when you are identifying which expression to use for the substitution part, you will always have to find the variable, the expression that has something like x equals something, or in this case, you have y equals something, okay? How do you know? Why is it that that is the one that we will use for the substitution? Well, as you can see here, y, the variable y, is just the same as this expression over here. So meaning, if we replace the y on this second expression, so we have originally 4x minus 3, this y, we can replace it by this expression. Why? Because they are equal. Y equals this expression. So this variable y here, we will replace it by the first equation, which is negative x minus 1. Okay? So basically, this is originally 4x minus 3y. But this y, according to the first equation, y is equal to this expression. So we substituted the y variable by this expression. That's why this process is called solving systems by substitution. Now, why is there a need for substitution? So let me just complete this over here. Okay. Now, if you can see here, how many variables are we having to solve in this particular expression now after the substitution happened? You can see that only x is the existing variable. We don't have to worry about y. And so, can we solve for one variable? Definitely. We can easily solve for one variable. Okay? So, first things first, always remember when simplifying an expression, we always check for distribution. Is there anything to distribute? Okay? In this case, we have this minus 3 or this negative 3 needed to be distributed to this group over here. Okay? So, we have 4x. Negative 3 times negative x is going to be a positive 3x. Negative 3 times negative 1, that's going to be a positive 3, is equal to 24. Okay? So there's nothing more to distribute. So what do we do next? The next step will be combining like terms. It's always like that. It will always be like that. So in this scenario, we can combine the ones with x's. So 4x plus 3x, that is going to give us 7x plus 3 is equal to 24. And now, the last part is we isolate the variable, in this case, our variable x. So for us to be able to isolate it, we need to subtract 3 on both sides. Okay, so we have 7x is equal to 21. And solving for x, we divide by 7 on both sides. Therefore, x is equal to positive 3, okay? Now, that is only the x value, okay? Are we done with the solution? Not yet, because this is just the x variable. So, how can we find the y? Well, if we go back on this original equation up here, okay, y is equal to negative of the x, so that's negative 3 minus 1, okay? Negative 3 and negative 1, if you combine that, that's going to be a negative 4, all right? So you have an x value, which is positive 3. You have a y value, which is negative 4. Okay? Now, what would be a quick way to check? Well, if you got extra time, you can always check how. Well, since this is an exact point, you can choose to use your graphing procedure, so that you can check if this is indeed where the two lines, why these two lines will intersect. And most likely than not, that is where it will be. Okay? That is why whenever we are solving, you can use any of the methods. Whether you use graphing, substitution, or elimination, they will all give you the same answer. Okay? It's just a matter of which method you are more comfortable using. All right. Now, aside from substitution, before that, so remember, when substitution, all you need to look for, it's easy to identify if we gotta use substitution or not, if you have one of the linear equations given to be variable equals. So x equals something or y equals something, that's already giving you the idea which variable to substitute. If you have something like x equals something, you can substitute the x on the other expression. All right? My personal favorite is solving by elimination. Actually, in this case, it's giving us the idea of addition, but basically, this is also what you know as solving by elimination. Okay? It's addition mainly because we are adding we are adding opposites of a specific, opposite coefficients of one of the variables. Okay? So let's work on this one. Okay, so pretty much what we need is to make sure that we have one of the variables that are opposites. Okay, they have the same coefficient but opposite signs. Okay, that's the important thing. Let me get rid of this. So they should have the same coefficient. So the numbers attached to them should be the same, but they need to be opposite signs. One is positive, the other is negative. Why is that? When they are additive inverses, so let's say I have plus 3x, and then the other one is negative 3x. If you add these two, what will you get? Positive 3x and negative 3x, if you add them, it will become 0, correct? Which technically eliminates that particular variable. It temporarily eliminates the x, which means you just have to solve for y. That is why, in general, this method is called the elimination method. We are eliminating temporarily one of the variables so that we can solve for the other. Okay? So how can we have the same numeric coefficient but opposite signs? First thing, you decide which variable you want to eliminate. Okay? Do you want to eliminate the x? Do you want to eliminate the y? In this case, since you can see that y is already a positive and a negative, then this would be a lot easier to decide. So we will remove y. Now remember, are they opposite signs? Yes. It's a plus and a minus already. But do they have the same coefficient? If you take a look, the first equation has a positive 2 as a coefficient. The other one is a negative 8. So how can we make them the same coefficients? Well, the easiest way to do that is to make them both 8. And in that case, for us to be able to make the 2 to become 8, what do we need to do? We need to multiply, okay? So in this scenario, we will multiply the first or the top equation by 4, okay, which will give us 3x times 4 is going to be 12x, plus 2y times 4 is going to be 8y, is equal to 48 times 4. So that's a 32, carry 3, 4 times 4 is a 16 times 3, plus 3, that's a 192, okay? And then, do we need to change anything on the bottom equation? No need, because we have a minus 8 there. So you have a 9x minus 8y is equal to negative 24, okay? And so now, from the name itself, the addition method, we add them vertically since they are aligned, okay? So we have here 12x plus 9x, that's going to be a 21x. Positive 8y minus 8y, that will give us a 0. So we eliminated our y variable. And so this time, if you add this 192 and negative 24, so basically you're subtracting. So this is going to be a 12, that's going to be an 8, this is going to be an 8, 8 and minus 2, that's going to be a 6. So that will be a negative 168. And then, if you solve for x, we divide this side by 21, we divide this side by 21, and x is now going to be equal to positive 8. Okay, 168 divided by 21, that's going to be an 8. All right, now, how do you solve for the y value? Well, you got two choices here. You can replace the x on the top equation, or you can replace it on the second equation. It doesn't matter. It will still give you the same value of y. So let's say we use this one, since this is a smaller values here. So we have 9 times the x, which is 8, minus 8y is equal to negative 24. 9 times 8 is a 72, minus 8y is equal to negative 24. We want the y to be by itself, so we subtract 72 on both sides. Oops, 72 on both sides, so this is now 0. So you will have negative 8y is equal to negative 24 and negative 72. That's going to be a negative 96. And if you divide by negative 8 on both sides, we will get a value of y to be equal to positive 12. Okay, so that is how we will be working with system of elimination. So remember, the important thing here is when we are eliminating one of the variables, okay, it doesn't matter if it is x, if it is y. All you need to remember is that they should have the same numeric coefficient, and that variable that you are trying to eliminate have opposite sides. So in order to make them the same coefficient, opposite signs, if there is a need for you to multiply one of them or even both of them, sometimes you can do that just as long as you have same coefficient but opposite signs of one of the variables. Once you have that set up, then you can do the vertical addition. You will get something canceled out. You can solve for one of the variables and then use that variable, replace that one of the original equations so that you can solve for the second variable. All right, so that's how you can solve by solving systems by substitution or by elimination.